Hi everybody, welcome back to my basement. My name is Chris Bauman with Miser Imaging, and today we're going to continue with some of our video tutorials on the tilt light sheet imaging system. Yesterday we went into a bit of a deep dive onto how the light sheet with the tilt was generated and some of the theory behind it and why we made some of the decisions we did in designing the product. Today we're going to switch gears a little bit and talk a little bit more on the application side. Specifically, we're going to talk about multimodal imaging and how the tilt makes multimodal imaging quite easy to do. So again, here's the tilt. On the right, we have the light sheet generator. This generates the light sheet and positions the sheet over the objective. On the left is the XY piezo stage that holds the sample and will then scan the sample through the sheet. So the sheet is fixed over the objective and the sample, it could scan through the sheet. The tilt works on nearly any inverted microscope, basically any laser system as long as it has a single mode fiber, and basically any camera. So if you already have a system that has a good camera, it's easy to add the tilt to it and use that existing camera. If you already have a system that's laser based and you have an extra fiber output on your laser, you could use that extra fiber output for the tilt. You could use any objective on the microscope. You could use low mag objectives like 20x to image whole organisms, or high mag, high NA objectives like a 60 or 100x TIRF objective to do intracellular dynamics. So it really allows you a wide range of application space and sort of imaging opportunities that other light sheet systems do not offer. It also works with with most imaging software. Since the sheet is fixed, the only thing you have to control is the stage. And the stage can also just be controlled with analog voltage. Makes it very easy for most software packages to incorporate the tilt into it. And finally, the tilt has very, very low photo bleaching and phototoxicity. If you recall from our talk yesterday, we use a fixed sheet and not a scanning sheet. That allows us to have a very, very low photon density within our sheet that minimizes the probability of forming the triplet state, which reduces bleaching and toxicity significantly. So let's take a minute and talk about some other imaging modalities other than light sheet. And you'll see why in a minute as we go through these. One of the more common other modalities out there in terms of high-end microscopy is point scanning confocal. Point scanning confocal is where you take a single fixed diffraction limited laser spot and scan that through the sample. And at each point, the fluorescence from that point is read by a PMT, and you slowly build up an image. Point scanning confocals can give you wonderful images. They're not exceptionally fast unless you go for a high-end resonance model, and they have fairly high photo bleaching. Resonant point scanning confocals don't really lend themselves very well to doing live cell imaging, especially any sort of long-term or rapid dynamic live cell imaging, but you get wonderful images from them. So next on the list is spinning disc confocal microscopy. In spinning disc, you have literally a disc with a series of pinholes spinning very rapidly, and your excitation light passes through that disc, and the emission passes through the disc, and the disc acts as the confocal pinholes. You get much less bleaching than you do with point scanning confocal. The image quality is not quite as good as point scanning confocal, but is still very good. But again, the photo bleaching characteristics of spinning discs are still fairly high, and it really will not lend itself to doing very long-term or very rapid live cell imaging. You're still going to get bleaching and toxicity. You get TIRF, and there's also sort of lumping in high-low and palm storm, the super resolution techniques with that. Again, TIRF requires a lot of laser power, especially high-low and storm. And storm and palm and storm specifically is really not very good for live cell imaging. With TIRF, you have the laser coming in at an oblique angle. It hits the cover slip, and you create what's called an evanescent field above the cover slip. And it's specifically designed for looking at things right at the surface of the cover slip, within about 200 nanometers of the cover slip. So while you're able to see focal adhesions and things of that nature, you can still get quite a bit of photo bleaching, and it's very difficult to do sort of very long-term studies with TIRF. And finally, you have structured illumination, or SIM microscopy. Structured illumination, and there's a wide array of systems out there that all work on slightly different principles, but the underlying principle is the same, that you're imaging your sample instead of with an even illumination of light, you're imaging your sample with some sort of structured light, whether that's stripes or pinholes or what have you. There's some sort of structure in the light. And you take multiple images by shifting that pattern slightly, and with image processing, you reconstruct a super resolution image, typically down to about 120 nanometer resolution. Again, because these require a lot of light and multiple images to get a single image, with structural illumination microscopy, not very well suited for live cell imaging, quite a bit of bleaching, of quite a bit of toxicity. Excuse me. So each of these imaging modalities has their sort of ideal application space. From trying to look at super resolution images to try to dissect the interactions and things that you couldn't see with normal microscopy, to confocal microscopy, where you're trying to get sort of the prettiest image possible. But none of these are very well suited for long-term live cell imaging. If you look at sort of the order in which the spinning disk is probably, of those, is probably the best, followed by point scanning, followed by TIRF and structured illumination. But remember, the tilt now can be installed onto any of these microscopes. We simply replace the stage on the microscope. And then you can continue to use our stage for the applications and imaging with these other modalities. So now, by adding the tilt onto these systems, you can now do long-term and/or high-speed imaging. In addition, work in some of these other modalities. For example, if you had TIRF and a spinning disk confocal, and you wanted, and say you could image an overnight experiment, you could image every 15, 20 minutes with the spinning disk without bleaching. Now you can use the light sheet and image every 5 minutes overnight, increase the amount of data you can get, increase the temporal resolution that you can get. And then periodically, every hour or so, take a spinning disk image to get sort of that nice, prettier, higher resolution image than you could with the light sheet. So now you're going to get your bulk of your temporal data with the tilt, and get sort of a broad overview with a prettier image with the confocal. So you use the tilt for the bulk of your imaging, and then you take periodic images with the other modalities. One example of this is a system we have at Rockefeller University at Allison North's imaging facility, where she's installed the tilt onto an iStim microscope. Again, the iStim is a structured illumination system, not very good for doing long-term imaging, but now she could do long-term imaging with the tilt and take a periodic super res image along the way. This has been working quite well. In addition, we've set the tilt up with the spinning disk confocal, in this case the X-Lite V3. In fact, we'll be setting one of these up today in the basement lab, and we'll be doing some multimodal imaging throughout the course of the next week or two. What's nice about the V3 is it has a bypass mode. So I could bypass the spinning disk, go straight to the camera, so I do not need a separate camera port that you would if, say, you had an Yokogawa X1 that does not have a bypass port. So in this case, I could use a single camera off the single port and switch back and forth between light sheet and spinning disk confocal microscopy. So that's it for today. This one's going to be pretty short. We'll be back tomorrow talking a little bit about, you know what? I don't know what we're going to talk about. We'll be winging it. So come back tomorrow and we'll see what we're going to do. Hope everyone's doing well. Hope everyone's staying safe. Take care. Cheers.